Thanks everybody for coming out, for being here. Thanks to the sponsors and Paul for having me. Yeah, my name is Richard. I work for AWS. I'm part of AWS Mobile, which is an organization out of Seattle that we run a bunch of services in a framework. So we have underneath our umbrella, we have AppSync, which is probably why several of you are here right now. We have Device Farm. We have all of the client tooling, so that is an entire framework called Amplify now. Before it used to just kind of be a ragtag group of SDKs that worked for different services. So I'm going to talk about a little bit how that's evolved. We also have Amplify Console, which is a new thing that we released for CI/CD back in November at reInvent. So I gave a presentation last night specifically just on Amplify, and since some of the people from last night are here, I didn't want to regurgitate information again, so there is different stuff. But I'm going to try to keep this a little bit more GraphQL focused rather than just overall generic, although I will talk about concepts that impact GraphQL. And depending on how I do on time, I'll either do a lot or a little of demos. So I'm assuming most people in here know the basics of GraphQL, seeing as this is a GraphQL meetup. Okay, cool. So my goal here is to talk a little bit about history on these and then to go into maybe some more advanced things and kind of why we've built some of the things that we have. So I was actually one of the two people that started both of these projects. In fact, I wrote the first internal papers for them at Amazon 2 years ago, and I wrote the first code for Amplify. So this is pretty end-to-end context. And actually 2 years ago today I was living in New York and I was a field engineer building some stuff for AWS Mobile before moving over to the service team. So a lot of this stuff comes from working with customers hands-on. So kind of starting from the beginning on what we tried to do was when I was in the field and building stuff, and I gave this analogy last night of you're talking to some friends and you want to build an app, and how would you do that, right? You would say, well, I want to build an app that people can pick me up from the side of the street and in their cars and takes me somewhere else, or can tell if it's a hot dog or not a hot dog or something like that, right? You wouldn't say, I want to build an app that has really cool login screen, or an app that sends analytics so I can track metrics and stuff, right? That happens after your business idea. But the truth is where we are today, and really kind of how AWS Mobile started evolving a couple years ago, was we had all of these needs, right? You wanted to get data in your app, whether that was just simple primitive types like integers, strings, lists, or objects like videos and images. But it's P0 today to add all sorts of security features in, like privacy controls, user sign up, all of these workflow things, custom business logic with compute in the back end, and then you're going to start making decisions around the platforms you're going to develop on. So some of the terms that were dropped before by the sponsors were things like, maybe you look at native like iOS, or maybe you start looking at the hybrid route like React Native or things like Ionic. But these are decisions that have to be made. And what we used to do a couple years ago that we've started pivoting away from is we wanted to work in a different way from just kind of throwing a myriad of services in. So has everybody in here seen the AWS Console? There's a lot of stuff there, right? And it's humanly impossible to know every single thing about every single one. It's just not possible. But we, the way it used to be was really P0 is, here's Cognito, here's how you do authentication and authorization. And then people would say, all right, here's how you do federation, even before actually explaining the use case of joining social logons and things like this, I want to just show log on with Facebook. Then we used to throw other things in here like S3, okay? So programming with S3 now, you need to start learning around things like keys and file paths and stuff and object storage concepts. And it got even worse when we would throw some other services like DynamoDB into the equation, to where we basically say to mobile or web developers, all right, start thinking about distributed hash keys and hot partitions and stuff like this. These aren't really concepts that everybody thinks about when they're building a web app. They're thinking about UX flows and accessibility, maybe rendering of data really fast, time to first interaction, stuff like this. So just kind of getting going, even if you just look at AppSync and you're cool, I want to have GraphQL in my app. Of all the features that that it has in it, you still have to learn a service, and you would still have to hook it up, which took a lot of work. And in fact, what we were doing with AppSync at the time when we were first looking at this problem, even though like myself and others were using GraphQL at customers, we didn't like day one set out to say we want to build like a GraphQL service with some other stuff. In fact, we were trying to solve some specific problems. We were trying to solve real-time data to clients. We were trying to solve problems around pagination and providing really performant bandwidth optimization. We were also trying to solve problems which I'm not going to really cover in depth tonight, but around offline programming. And it turns out that GraphQL actually has a really nice model of normalizing data when it comes down to the clients and having an offline model. So if you were to build an app like that, you end up with an architecture something like this. And on one hand, you look at this and you're like, well, this is really confusing. Can I go away from this architecture? Maybe. I mean, you could look at like some BAS type solutions and so forth. But there's a reason why services exist, right? Your decoupling concerns. You eventually want to scale. And that was another reason why we ended up going down the GraphQL route as well, which I'll talk about a little bit later, was when we were really going through this problem of providing data to mobile and web apps, but from an AWS perspective, we didn't want to provide something that was like super simple to use with like just a database connected to it or something that anybody could get started with, like a to-do app. But if your app like became the next hot thing and took off, it falls over and you need to re-architect your back end. Instead, what we were really trying to do is provide something that customers could graduate and their back end could evolve without them needing to completely blow away their infrastructure. And it turns out GraphQL actually has a really nice pattern for that, right? With things like resolvers and so forth and connecting them to different data sources. You really can just focus on your data model and then interchange the actual storage engine in the back end that you later persist to. So if you take that architecture I just showed and said, okay, this makes sense, but I'm kind of savvy here, maybe I could actually tackle some of these things myself. So I'm going to kind of like go through a couple of slices here. I'll look at auth, and then after that I'll look at the data problem and talk about how we got to where we are. So let's say you built an auth system. Is there anybody in here that thinks like auth is like super simple today's day and age? In fact, this is slide 1 of 2, just to talk about some concerns that we go through every day, right? So you start from, all right, maybe I'll just do some basic user, sign up and sign in. And then you start saying, oh, well, they also got to put in like their badge number or something else, or their street address. And then, of course, I want all of these MFA controls and so forth. And then, like I mentioned before, I also want them not to just have to put in everything, but if they already have like a Facebook or Google Plus account, they should be able to pop that in. And then, right, you get some of these requirements and you start looking at all these standards. And it depends, like maybe your customer is an enterprise customer and they have enterprise needs. Maybe, they have their own home-rolled solution. Maybe it's something else, and you get these terms like OpenID Connect and Secure Remote Password Protocol, and then JSON Web Tokens, and then refresh flows, and then PKCE, which is, Proof of Key Exchange. These are really like technical things that exist because it's a really hard problem to actually solve security at your barrier, which is your application. And then even if you solve them a little bit, like you start looking at those platforms, the way they behave is different on platforms. So for instance, you might use one control for an OAuth flow on your SPA that works great, and then you throw that into your iOS or Android or your React Native app and it gets rejected from the App Store because how callbacks are intercepted by applications and what you actually have to use on the native platforms. So these are really like hard problems, and like just going through this is like months and months, if not years of work. And then it's really not done because we see every single day in the news, we see like this data breach over here and then this use case over there. And when I used to be in the field a few years ago developing these things, like we did not have the same pushback from just like basic, small developer shops building things on requirements. Like everybody today has requirements on like, I need this app to work for public access, and then when people sign in, then they can just get per user identity and only those users can see things. But wait, when somebody views this page, if it's got some editor system or blog system, everybody can create things, but only the people that created them can edit or delete them. And then let's nest this with like, oh, maybe public people can view things, but only when they're logged in, then they can comment on things. Or friendship patterns, right? Like the classic Facebook case of one of the areas where GraphQL evolved from, right? Like only my friends can see my photos. That's actually pretty technical to do on the back end and scale. You usually need like multiple relationships of storing user entities in one place before you can actually fetch data from another. I'm going to talk about this a little bit more later on the fundamental problems behind this, but these things are really, really complex, and just tackling this, we haven't even built a GraphQL API yet, right? So we kind of started here and tried to say, all right, how do we abstract some of this? And I'll talk about that in a little bit. We do some other things under the covers if you really want to get crazy scalable too, such as signing requests. So, you know, not a job interview, but hopefully everybody realizes like encryption is completely different than signing. You know, this is how actually at scale we use a hash-based system at AWS to verify the authenticity of requests. And this is another tough problem. Like essentially what we do is we take these short-term credentials, we actually do a 4-part HMAC on all your requests so that as they come in, they actually get validated, and if like devices or users became compromised, those credentials can expire. So you essentially get mathematical certainty that your requests are valid on who they're coming from. But even doing this and to have like nanosecond type crypto offloading on the back end is a really tricky problem. And then finally along this, like one of the terms that I mentioned before, you know, even just the simple problem that you might think is simple, like storing usernames and passwords in a database, you can't get away anymore if you look at the news and you see things like people hashing passwords and then a database gets compromised. So you start getting into techniques like SRP, which is Secure Remote Password Protocol. It's actually pretty interesting if you ever look at the Stanford website on this. Basically, this is a way of taking really large primes and computing a password verifier so that the password actually never leaves the device itself. It never goes over the network. And that means that if, you know, attackers actually start sniffing your traffic and things like this, or you have exploits, they can't, you know, reverse engineer and decipher how this works. But even doing that, again, I go back, you know, where did we start from in AWS Mobile? We wanted to make these things simpler. This actually works differently on iOS and Android versus the web versus React Native, because like you have to use techniques like you know, Montgomery multiplication, which actually moves like matrices of computation for these large primes from one domain into another. And if you're on like React Native, for example, you don't have like JIT. So this thing takes like 60 seconds to compute, so you have to do other things behind the scenes. So this is all to say just the auth piece is really technical. Now let's look a little bit deeper into the data and storage piece of, you know, that slice of the architecture before we get into a little bit of Amplify. So sounded like everybody in here is pretty familiar with GraphQL. So, you know, again, GraphQL just a spec, not actually an implementation, although there are a lot of popular implementations out there. We actually use the reference implementation for JavaScript in the Amplify CLI to do some of our GraphQL compilations, which is pretty cool, so that it's always, you know, spec compliant as an open source platform. But you can use anything in the back end, right? It's not a graph database. You could speak to a graph database. You can speak to NoSQL. You can speak to Redis. You can speak to a file system. And the fundamental thing, right, everybody's familiar with, like the old way of doing things would be, you know, round tripping to different endpoints, getting in items, then, you know, or getting a list of items, and then for each item, you know, getting the details behind it. Classic N+1 problem in GraphQL. But, you know, if I want to start then going through comments of events or, you know, comments on a post, even if you built this thing and you rewind to what I just talked about a second ago, what if I wanted to just allow editors to see the comments on a post, or when people are signed in, or that friendship relation, right? You know, it's not just, you can't look at these problems in isolation in just a little box. Actually, your entire app infrastructure and how they relate to each other is pretty important. So if you look at the GraphQL world, what ends up being the tricky part of this? Well, the tricky part ends up not being like the GraphQL endpoint with a schema. Actually, that's pretty easy to do, whether it's in Amplify or other things. The tricky part is actually the scalability on the back end, where you're going to fulfill your data fetching needs, essentially your resolvers, right? So you might need to partition this out across multiple hosts, make sure it's well distributed, make sure that it's consistent so that any of your clients, they get, read after write consistency. If you've got multiple clients that are doing fetches, they're actually going to get consistent responses after one of your clients has done a write. There's actually a lot of large-scale distributed system problems to do here. So one of the interesting things is, if you rewind, how does GraphQL work, right? You have a schema. Everybody familiar with SDL? All right, cool. I should probably ask that the other way. Is anyone not familiar with SDL? SDL is probably the most popular way these days of building a GraphQL schema. We really go quite heavily into it, and there's a reason why, right? So, if you define SDL and I build a schema and I attach a resolver to return some data, and we look at this in the context of that last slide. And then I bring this all back to my central point that I started with. How did we end up where we are today? It wouldn't have been just good enough to only abstract some of the services behind the scenes. Instead, yes, you can use AppSync and so forth to build out resolvers, and I'll talk about a philosophical approach that we have as a whole to Amplify around that in a minute. But, we want to even make it easier so that you can get to your end result. And your end result essentially is building a GraphQL API that fulfills data for your application. It's similar to, I was talking about this last night, if you've ever read the Don Norman book on how design of everyday things. It talks a lot about how doors are designed and so forth, and you talk about a shelf, right? Your goal is to hang a shelf. It's not to buy a bunch of screws and a screw gun and figure out how that shelf is put together, even though you might have to do that depending on your circumstances. In a similar way, we want to build these tools for everyone so that mobile and web developers can quickly build their applications. Not that they have to learn all of the innards under the covers, but as their business graduates, then they can actually have those things in place that they can learn more about them and tweak them as their skill needs require. So, when I said I was just going to talk about data, I didn't mean just talking about GraphQL, right? It's probably pretty doubtful that a lot of people are using apps these days that they're truly satisfied that don't have some sort of rich content with it, right? Maybe you do have a to-do app, but the majority of apps these days are showing some sort of image or thumbnail or video or something else, or live streaming data and so forth. And the classical way that if you watch over the past decade of how people build these rich applications on AWS is they store images and so forth on S3, and then they store the metadata as references to them in some sort of database, usually something like DynamoDB. And this is another thing that we try to encode into some of our patterns is allowing you to do this in an efficient method. And AppSync actually supports a method to do this with an S3 input type. And what will happen here is if you've actually got this in your schema using our SDKs, your mobile and web developers can just think in terms of a GraphQL mutation or a query. So if they write data that's pointing locally to a file, our clients will actually upload the data first behind the scenes in S3 and then send the mutation, and the data will actually be written to a database pointing to that file. And then we do the reverse orchestration on a read. But the point is you don't actually have to build all of this, and I'm going to talk about why that in a second. GraphQL subscriptions, again, you're probably familiar with these, right? These are one of the 3 primitive types in a GraphQL schema beside query and mutations. So they're long-held connections, normally via a WebSocket, that respond to changes in data. The one note I'll make about this that's pretty cool in AppSync, the way that we developed it, is so we have all of these high-performance templating resolvers built into the system so that you can get single-digit millisecond latency execution on the back end, so that you could do writes and reads back and forth from the client in a few hundred milliseconds. And we also have an escape hatch with a Lambda function. And the important point of bringing this up is, since we support Lambda functions and our subscriptions execute in results to mutations, you can essentially hook up a Lambda function to anything you want in your AWS account, and you're realistically making anything real-time inside your infrastructure, because you could write and read to other services, or you could just go to some third-party API. It's up to you. And the final thing, before I get into where we got from here and how we're making a lot of this easier, is I mentioned earlier on the evolution and what we're trying to provide to customers of a really simple, easy way to operate, and then your backend can graduate as your business grows. This is another common pattern that we see in the real world, which is people starting basic with just like DynamoDB, writing and reading data, using it for querying on indices and so forth. And then they later want to do like full text search, fuzzy search, and things like that. And the common pattern to do something like this is, later to add something like, search posts in here, and then pass that strings for like, maybe a full text search on like part of a word or something, or a fuzzy search. But you effectively would, if you were building this yourself, you would manually hook this up to an Elasticsearch cluster with a Lambda and everything else, and now you have this really comprehensive database on the back end, but just building that up takes a lot of time and tweaking. We do this automatically under the covers for you as well, through some of the features that I'll talk about next with Amplify. So, hopefully that was like an overview of, there's a lot of moving pieces and complexity going on. Our goal is to make this easier. So how do we do this? Well, this is where the Amplify Framework comes in, right? So Amplify has become, since we first created it, we've kind of evolved and learned from like our messaging and stuff. And we tried to really simplify as much as we could, and we're still working on that, but from a high level, Amplify is a brand for AWS Mobile that we're offering. And there's two key pieces right now. So there's the framework, which is explicitly focused on the front end and mobile, the client developer experience. And it uses services behind the scenes like Cognito, like AppSync, like S3, like DynamoDB. And then there is the Amplify Console, which is a CI/CD tool for hosting. So continuous deployment of your SPAs and so forth, builds on the back end, cache invalidation we just released and so forth. So this makes things, if you actually, instead of building your own either web server to host your app or using S3 and CloudFront, you can just use Amplify Console and deploy in seconds your React or whatever app you're using. So I'm going to focus on the framework here in this presentation, especially in the context I'm going to focus on it heavier in GraphQL. So this is a client framework that has certain principles that we started as. These were actually part of the original paper I had written internally on Amazon on how we wanted to attack the problem. So the first is, rather than focus on teaching services, we wanted to teach categories around the use cases that you were going to build into an app. So we've got a handful of them. We've got things like auth, like API, storage. Core is another one that actually allows underneath the covers in the library framework for the categories to communicate with each other in a pub/sub system. We try to very rarely, if possible, add categories. We will add some more in the future if the use case necessitates it. But the biggest reason is if we just kept on exploding our categories, then we'd be in the reverse problem of just exploding services, right? And that's what we're trying to avoid here. We also, on purpose, so we have declarative interfaces. And, a lot of times the word declarative is thrown around, but this actually means something very specific. And the specific meaning is this is open sourced under Apache. And our team operates in a full open source manner. And this is really important. So not only, open source, yes, code's out there and so forth. But if you follow Amplify repos or anything else, you see we put all our RFCs around any of our new features on GitHub. We work backwards from community feedback. We have an entire analytics system that we've built around our GitHub responses, as well as people's reactions to them, and emails come through, and Stack Overflow. And we use that with a trending system internally to see the biggest pain points for people and up them on our sprint process priorities. Our on-call actually works through all of these issues all week. So when our on-call and our secondary are doing that process before they rotate off, they not only go through these issues and work on bugs, but they're actively on a Gitter channel answering your questions all day long. We're also investigating potentially either a Slack channel or a Spectrum community. But this is not just like lipstick. This is a full open source project that we're passionate about. And the reason that we have these categories and declarative interfaces is That allows us to change the implementation later if either we see fit or if customers want to provide alternative implementations. So for example, it's not auth.signin with Cognito, it's just auth.signin. And you'll notice that we've actually done this in a few places. So for instance, auth actually supports in different pieces of it. One of our partners is Auth0, and so it works across both the JS side as well as on the native side. And you'll see this over time when people give different plugins, essentially, is what we give. We actually have a provider model if you're familiar with like adapters and so forth. So like the analytics category, for example, the base provider, if you just install Amplify out of the box, uses Amazon Pinpoint. But if you switch the provider through just one line of code, it can send your analytics events to Kinesis. And also, it's Kinesis Streams right now, but somebody in the community just provided a plugin for Kinesis Firehose. But the important point is like the application developer code is the same, so is their API. It's just going to a different source. Some other things around this too is centralized config that automatically gets built up, not through just our tooling, but through the libraries themselves that use it. So this is another way that mobile and web developers don't need to think too much about the API calls. They can actually do config singularly rather than kind of have spaghetti code for different flows. And around these things, when I showed that infrastructure and architecture, we actually try to be opinionated with these best practices on what it takes to scale your business build in. And there's a bunch of success stories out there that you can see on the web. Companies like Aldo Shoes, Ticketmaster spoke at reInvent, right? And you're getting all of these things baked in. But normally, the key here, and it's a really subtle thing that allows us to get away with having some of these opinions and best practices and categories built in, is that we try to provide escape hatches for when people are in the 10% or they want to do like some brand new custom things that are just getting invented. So for instance, I'll use an example. We will probably never add in the framework a way to like configure a DNS endpoint through Route 53, right? Because mobile and web apps, yes, they'll use DNS, but that's an admin thing that somebody would set up. Unless you were building some sort of administrative app, which is a very rare use case again, you probably wouldn't do that. But we actually enable you to do that through Amplify, because how we build out the library is we take all the service definitions when they're published. So this is actually an online spec that you can find called Coral to JSON, and any AWS service actually publishes this. And then we do code gen on it and create what we call the base SDK. And then the libraries get layered on top of that. And then any framework components like React or Vue or Ionic and so forth or Angular are on top of that. And what this means is that if you use like auth, for example, you can just tunnel down through essentially our escape hatch in the library and directly call any AWS service method if you wanted to. Or your own REST API behind the scenes if you need to do that. And we've got similar concepts built into the CLI with like creating your own directive for your custom transformers and so forth. But it's these kind of philosophical approaches that'll give us some of this flexibility to do these techniques. So what is the framework made up of? The framework started as a JavaScript library that has support for React, React Native, all of these UI components, Angular, Ionic, Vue. We have pulled in the iOS and Android for Swift and Java SDKs into the overall framework. We still explicitly call them SDKs right now because we're slowly transitioning them over time to have the same type of interface and programming model that the Amplify JS library has. You might have seen this. We started in November and actually just released something last week, a couple of waves on auth to do this. So it's not namespaced as auth just yet, but you'll see actually the AWS mobile client that has the same APIs in it with like the declarative interfaces for iOS and Android that give you the simplistic model with a centralized configuration. So over the course of 2019, you'll see more of this come on the native side as well. And then besides these things, also the other big piece that we have right now of the framework is the CLI toolchain. So we call it a toolchain because it's kind of separate from the CLI itself. So the CLI is the main structure that allows us to do a lot of the automation and kind of calling different packages underneath the covers that give you different pieces of functionality. And when we add in these pieces of functionality under the covers, like the GraphQL transformer that I'll show you, or like CodeGen for Swift and iOS and TypeScript and JavaScript and Flow, those are always different packages in the mono repo that it's able to plug in and leverage. And we'll add more and more of these over time. So we have the categories on the left-hand side. And let's jump into what this looks like a little bit. Okay, so is Amplify CLI, who in here has used it before? Okay, maybe like a third. Okay, this is good. So I'll demo this in a second. So the flow on the Amplify CLI is you install it via npm, and then you'll navigate from your terminal into your project. So it could be an iOS, an Android, or a JavaScript project. And I'll do one here in a second. And then you just use a very simple, the verb in the category. So Amplify add API, choose REST or GraphQL. My demo, I'll do GraphQL in a little bit. Then you do add storage. You can add, NoSQL database, or you can add object storage like S3. Another really popular thing on this is Amplify add auth. It's got a bunch of best practices built in. And then you push. What happens behind the scenes is, again, this is a best practice thing built in and a scalability thing. We create a root stack in your AWS account with CloudFormation, and nested stacks underneath that. And we partition them in a way that it's really flexible for you to send a lot of data up there and create a whole lot of model types without overwhelming your CloudFormation deployment. This also supports a whole lot of, now we've released enterprise workflows. So you can use a regular AWS user if you're just getting started. You can use AWS short-term IAM credentials with profiles. You can even use MFA on this. We've also got team workflows and a Git style environment support on this, and even sharing your projects. So the big thing, though, from a GraphQL perspective is what this has in it when you add an API is what's known as our model transformer. Or rather the GraphQL transform that has a model type directive that you can set on a type in the library. And the basic idea is you just write SDL, so similar, I have type post, maybe I give it an ID and a string, and I annotate it with model. And this, just doing this alone, will actually build you an entire backend. In the transformer flow, you can also decide different authentication and authorization techniques on this that you can do. So we have a bunch of directives. We're going to be adding more, like you'll see on our GitHub repo. We've got an HTTP one, a function one. We're going to add one soon for pipeline resolvers. Depending on how quick I go, I'll talk a little bit more about pipelines in a second. But a lot of the really important ones are listed here, like the searchable one. That whole architecture I showed before of hooking up and streaming to an Elasticsearch cluster, all you have to do is add this one annotation in, and we do it all automatically for you. Under the covers, you don't have to wait anything. Well, you have to wait a few minutes for the cluster to spin up. But after that, you don't have to do anything. We have a version one that gives you a pretty fancy conflict resolution system. If we were talking offline today, I'd go into details on that. So we can do connections, which is connections through multiple types, pagination built in. And let's talk about the auth one for a second. So a quick aside, to rewind back from everything I was talking about before, authorization in general actually has a well-defined industry standard set of rules. I'd actually encourage you to look up Wikipedia link for an access control matrix. This was actually created by this computer scientist known as Butler Lampson. And if you start studying anything, like you look at the IAM controls in AWS or other cloud providers, you look at file systems and so forth, what's the primitive thing, right? You actually need some sort of authorization metadata to give users or groups, right, the actual roles, access to objects, right? There needs to be some sort of rules and relation between the two. So why am I bringing this up? Why is that important in terms of the auth rules that you can do inside of AppSync, or honestly if you were building your own system? Is because that metadata can be provided in different ways. So it could be provided to where you auth against a system and have a JSON web token, and inside of that maybe you have username, or you have the groups that they're in, or other sorts of claims and attributes, right? So whether that's coming from Cognito or a third-party provider like Auth0 or Ping or Okta, that essentially is metadata defining rules. Another way it could be is if you're passing data into your backend, which in the case of GraphQL is a resolver. If you don't want your resolver to actually look at that metadata and the rules passed in, it could dynamically reach out to a data source, like a database table, and it could do the runtime checking against that data source. This is usually what we do behind the scenes when we want to scale more on like group membership, for example. So to like make this concrete, what you'll see if you ever like crack open some of the code for what we do on some of our auth rules, on some of them we look at the JWT rules that come in, like the context, and look at the username coming through. Other cases, we actually mark the object itself, like let's say it's a blog post with like a name and a content and so forth. We'll put like an owner field on there. Like it's an actual attribute, and we runtime check, we do a conditional check against it. Or we do an existence check if it's like a group, and we'll look inside of a map or a set. So this is kind of the fundamental problem that you have to do. And what we do is we take this fundamental computer science problem and authorization routine at runtime, and we give you this set of auth rules. And this is just like the simplest case that you can do here. But for instance, I want to allow the owner coming through, and we default to the username, but you can also provide, custom ownership attributes. We allow them rights to do operations. And then on this one, I'm also saying that anybody that's in the editors field or the owners, they can do mutations on this, right? So you can get fancy and nest these and so forth. But fundamentally under the covers, what we're doing is we're taking this model type that we have here on auth rules, and we do code gen, and then we insert that, and we either use the metadata coming from your tokens coming in, or that's set on the data source itself, or a combination of the two to mirror them. And what's pretty sweet about this is you can do crazy amounts of stuff using GraphQL as a pattern, right? Because if you think about it, like GraphQL enables you to reach out from one data source to get the results from that data source and then use it actually for your data fetching. So rewinding back to like that friendship pattern that I mentioned before, maybe you put all your authorization rules on like, a friend and then the friend ID or the friendship relations in one data source, and then if that comes back truthy, then you fetch the results from another one. Again, talking about patterns, I talked about the searchable one, we make that easy. Before I showed you the common architecture around object pointers and relations and pulling those down from. Our transformer handles this as well. I don't think I did a good job on my showing the screen, but this is on the right hand side. You can add an API, but if you put in your model transform an S3 object and you give it a reference down here, like my picture type, we automatically build out on the back end again that pointer and that relation system as well. And again, our SDKs will coordinate this, so you're just doing queries and mutations. All right, I have some more slides to show you in advanced stuff, but I want to show some demos. If this thing will let me exit. Okay, here we go. All right, so the way I'm going to start this is...
Make everything bigger.
Yep, I will. So I just did a Create React app a couple minutes ago before I started. How is that? Bigger? Can we read that? Okay. So I'm going to do Amplify, just so you can see. What do I call this? GQL. Toronto. My new Mac keyboard has been doubling the D's recently for me. So I will do Amplify init. So I, npm install Amplify CLI, or at AWS Amplify CLI. It's going to ask me some questions. I'll make this a test environment again. Like I mentioned, we support a Git style workflow for multiple environments. It's going to ask me my code editor. You'll see why in a minute. It's already detected that this was a JavaScript project. If it was like in an Xcode project, it would know that. Hey, look at that. Knows that it's React Native too. We look at like the folder structure and so forth. Also knows src and the build paths and the build command, start command, and so forth. It's going to ask me if I want to use an AWS profile. I could use an MFA one. I'll just use my default one. And now it's just going to initialize the project. So, like I said, this is like the shell behind the scenes that we create. The root CloudFormation stack and just an S3 bucket with a couple of pieces of metadata that we use for deploying some things. After this, we'll basically have an empty project that we can then use that verb noun thing, so Amplify add auth, add API, and so forth. This one's pretty quick because it's the basic thing. When you start getting into larger stuff, like if I added that searchable thing and it's got to spin up a cluster, it's going to take a few more minutes. At any time, you can do Amplify status, and it's going to tell me, what I have in the project. I've got nothing. If I wanted to do Amplify add auth, to start there, I could do this. And it's going to do some things like I could just press enter and it'll set up the default config. I could manually step through everything, or I could learn some more information and it tells me what it does by default. Instead, what I'm going to do is Amplify add API. See, I told you the double D. I'm going to select GraphQL. I'm going to leave it as GraphQL Toronto. If I wanted to, I could also, we try to inject some intelligence through some different flows. I could actually add user pull things, and you could do the add auth straight at this point if I wanted to. But I'm just going to use API key. I could provide an existing schema, but we try to give some help. So we give a guided schema creation, and I'm going to create a to-do system. I could also do a one-to-many relationship and show some of that connection stuff that I showed before. And I say, yes, I'm going to edit the schema, and this is where that whole, knowing my text editor came in. So, got VS Code here, and I'll add one thing like rating, just to show you I'm not cheating. So I'll save this. We're going to go back to that in a second. I'm over here. Press enter to continue. And now I do Amplify status again. Right, and it sees that it's in the create. So it already told me to do Amplify push. So I'm going to do that. It's also going to ask me a couple other questions, like do I want to do code gen? This is where we used GraphQL.js. We compiled it successfully. I do want to do some code gen behind the scenes. I have already created this API, so rather than waiting a minute for the DynamoDB backend and everything to be created, I'm just going to cheat and show you what a working project looks like, and then I'll show you that that one was built. So let me skip over here. I did these in US East. And I think I called this, oh, actually, I'll show you a trick. So this is my the meetup that I did last night on just Amplify, but I built the same backend. So this already has an Amplify project in it, just to show you what this looks like. So this is a React folder structure, right? And what happens in the project is we actually create a little Amplify backend, and we have information in it, such as the API definition, and here was the schema I built last night. So that schema last night, I actually added a priority field, for example. Make that a little bit bigger. But what you can do at any time, once you've added something to your project, is I can do Amplify Console. And for any of the categories that I've added in, it'll allow me to just go straight to the console feature for it. So this is actually the schema that it builds out for you. And you can see it adds a whole bunch of stuff. Let me zoom in a little bit. It would help if I press the right buttons. There you go. Right, so we have a bunch of things like input types, filter types it creates. If I scroll all the way down here, you'll see this is my to-do type, ID name, description, priority rating. We automatically create subscriptions behind the scenes for you, queries on get and list, create to-dos and so forth, stuff like that. Build out data sources, so it automatically creates a DynamoDB table. And I can start querying my data and so forth. In fact, just to show you that it is your data, I can click on this at any time. And it's actually got my items in here. So I've got a bunch of to-dos that I created. And in the console, if you're familiar with GraphQL, we have a very similar interface. I could do Toronto, GraphQL, meetup. And we'll give this a 10.0 rating. And what else do we want? We'll pull back the priority, but not the let's leave the description. It's not going to let me back. All right. So I'll add this, right? And it's my data in my resource that I own. I could also do some filtering and so forth. So let me build this one out again, just so you see how I did it. So I mentioned that we add in behind the scenes a whole bunch of things automatically for you to make the process easier, right? So I could list these, I could list my to-dos, get all the items that came back, like name, description, let's get priority. Right, so that's giving me everything in my database. If I wanted to, I could limit this, because we have automatic pagination in, let's say to 2 records. And when I start doing this, I can get a next token. Right, so it actually gave me the 2 items with an encrypted key that we encrypt on the back end automatically for you per client, so that even if you wanted to pass this in as a pagination token, we're even offloading the heavy work of people inspecting your traffic or exploiting your system and getting pagination tokens that might have impacted another system. So this happens automatically, built into the service behind the scenes. I could also do some more filtering on this. Right, so let's say I wanted to look for any description that had GQL in it. Oops. So let's say I want contains GQL. Right? And it found my record. Right? So all of this out of the box. And this project, and you'll switch over in a second. Yeah, this one's actually done. So we'll go and I'll prove that we built that one. But I mentioned before that with this, right, I selected code gen. And so when you do code gen, right, usually also people getting started with GraphQL have to write their queries and mutations and subscriptions. So we automatically do this. We put it in a GraphQL folder, and you can see I've actually got my queries, mutations, subscriptions built in. So not only do we pull down the introspection schema for you, but we walk the AST and populate default queries and mutations, which you can of course later just delete fields, because it's easier to delete something already working rather than having to learn from the ground up and build things out. So literally building a React app now that you want to hook up to GraphQL is as simple as I pull in my config file, so the Amplify CLI actually creates this exports file in it with some configuration information around my endpoint. So you can see some of these things built in here. It's API key, we default expire these in 7 days, but you can extend them to be longer. I installed AWS Amplify and AWS Amplify React. Oh, yes. Let me close this down. So I installed AWS Amplify, and I can pull in Amplify for our top level config, so it knows like my GraphQL endpoint, or if I had auth things in it, would know that. I pulled in GraphQL operation, which is a lightweight client that we have to make GraphQL queries, mutations, and subscriptions super easy. You can of course use the Apollo client as well if you're interested in that, and we have an SDK with Apollo links that plugs into it as well. And then I imported those auto-generated queries and mutations. So just to show something simple here as like the most basic case you could ever do, I just have a couple of functions here, a mutation that I'm going to pop up an alert when it happens, and then a list operation that I'm going to list everything, not really the most legible, but it'll get the point across, with a couple of buttons. So if I start this guy, I'll make the buttons big, and I'll also make the console big too, so you can see that. All right. So this was our table. If I run a query, yep, it's returning some stuff. So let me delete these just so there's no man behind the curtain. Oh, I need to. Why is it not letting me? There we go. Oh my. I think I lost the formatting now.
Command 0.
Command 0?
Reset it and create this up.
You saw the at the bottom, right?
Is it at the bottom?
Yeah. It says logos unpleased, defined but never used. Or is it just a word itself? I don't know. Just a
Oh, yeah. No, I'm trying to get the buttons up top. Let me try refreshing it. All right, I'm gonna go the old faithful route here. There we go. When in doubt, switch browsers. Cool, nothing's in there because I deleted it from my table, right? So if I inspect this, all right, so now I'm going to do GraphQL mutation, right? I think I botched something here in my demo. Let's do an add. Okay, there we go. I must have had a typo in my mutation. Oh well. Well, point across. That's how easy it is to get this stuff set up. And to just show you, no man behind the curtain, this was the one that I just set up a second ago. So if I do Amplify Console, right, you can see actually this one just has description and rating. So it's everything that I set up before.